Okay, welcome back to AP Calculus BC Block 2. I want to take a look at a problem today to kind of review what we were doing right at the end of the winter term. We're going to take a look at 2019 BC6 if you're scoring at home or even if you're alone. What? You thought the bad jokes would end just because we're online? Never. If you would like to take a pause, Google 2019 BC6 and try the problem on your own, go right ahead. And then press play and we'll go through the solution. Well, welcome back. So here we go. We're given a function f and we're given a tangent line at the point 0, 3. It's very clear on the problem that that's 0, 3. It's also clear that this is -1, 5 up here and 3/2, 0. Part A says write the third degree Taylor for f centered at x equals 0. Okay, so the first thing we'll do is we will regurgitate our Taylor series formula for any function f centered at x equals 0. Okay, we know that, we love that, we're ready to go. We're going to go over here to our picture to get f prime of 0. And we can quickly deduce that that's going to be -2. So here we go. F of 0, 3 minus 2x. Double prime of 0, 3 over 2 x squared. Triple prime of 0 minus 23/2 over 3, which will be 23/12 x cubed. There's our Taylor series. Now, I'm a pretty smart calculus student, and I know they wouldn't give me that 4th degree if I wasn't going to eventually need it, so I'm going to go ahead and write that down. Plus 54 over 4 factorial x to the 4th. Which I know is 54 over 24 or 9/4. So I'm just going to write over here 9/4 x to the 4th. I'm going to circle this. All right, let's go on to part B. Part B says write the first 3 terms, first 3 non-zero terms of the Maclaurin series for e to the x. Okay, I've got that in my pea brain. So here we go. E to the x, approximately equal to 1 plus x squared over 2. Now, the second half of part B says, give me the second degree polynomial for e to the x times f of x from part A. Oh, I think we can handle that, right? So here we go. We're going to say e to the x f of x. Now, this is just the second degree. So here we go. We're going to take 1 plus x squared over 2, and we're going to multiply it by this polynomial from part A, 3 minus 2x plus 3/2 x squared. Now, I'm not going to write the 23/12 x cubed because it's to the 3rd degree. And the problem says, give me the 2nd degree for this product. So here we go. Soyez prudents, mes amis, and multiply this out. So 1 times all of those, 3 minus 2x plus 3/2 x squared. X times all of those, plus 3x minus 2x squared plus 3/2 x cubed. I don't think so because we're only going 2nd degree. And then here, plus 3/2 x squared. And that's it, 2nd degree. Combine like terms, 3 minus 2x. I think this is supposed to be a 3x here, right? Minus 2x plus 3x, so that's x. And then plus 3/2 x squared plus 3/2 x squared. So that's 3x squared minus 2x squared is plus x squared. 3 plus x squared. Very nice, okay? So now we're going to move on to part C. Now, part C sets us up an integral. And part C defines the integral from 0 to x of f of t dt. Now, remember, that's from part A. And we're defining this as h of x. And so what we say here is use the Taylor polynomial to find an approximation for h of 1. So we're going to use this polynomial here to find an approximation for h of 1. Well, if h of x is the integral from 0 to x of f of t, what would h of 1 be? H of 1 would be the integral from 0 to 1 of f of t dt. And what are we going to use here? We're going to go 3 minus 2t plus 3/2 t squared minus 23/12 t cubed dt. Okay, let's grind that out, do some calculus, work that polynomial through, and do our magic and see what happens. Okay, so the first thing we're going to do is we're going to integrate. And we're going to get 3t minus 2t squared over 2, t squared, plus 3t cubed over 6, t cubed over 2, minus 23 over 48, t to the 4th. We're evaluating that from 0 to 1. Well, the 0 part goes away. We're just going to plug in 1. And my answer here is going to be 3 minus 1 plus 1/2 minus 23 over 48. Now, as you know, that's full credit on the AP exam. But hey, this is not the AP exam, so let's get a common denominator and let's go home. 48 times 3, 144. 144 minus 48, 96. 96 and 24 is 120. Minus 23 is 97. 97 over 48. Don't try that at home alone, kids. 97 over 48. Okay, now let's go to part D. Part D says, it is known that the Maclaurin series for H converges to H of X for all real numbers. It is also known that the individual terms for H of 1 alternate and get smaller. Is that true? Let's see. 3 minus a positive 3 minus 1 positive 1/2 minus 23 over 48. Looks like they're getting smaller to me and they're alternating. So what does that mean about the error? Dramatic pause. That's right. It's less than or equal to the next term. But what would the next term be? Let's go back. That's that 9/4 x to the 4th coming back into play. So here we go. What would that have been out here? That would have been plus 9/4 x to the 4th. And when we integrate that, we would have had 9/4 x to the 5th over 5, which would have been 9/20 x to the 5th. And at 1, it would have been 9/20. So essentially, we're saying here that that's what this number would have been down here. So let's go over here. We would have said the error would be less than or equal to the absolute value of 9/20. Well, how does that compare to 0.45? Because it says here, we have to show that the approximation differs by at most 0.45, but I showed that it differs by at most 9/20. Oh, 9/20 is 0.45. I guess we win. Isn't that awesome? I'll see you guys on Thursday. Have a great day.